Hey everybody, thanks for tuning in. I'm John Boker with Haviland Pool and Spa Products, but some of you might know me as the legend from our YouTube video series, Legendary Pools and Spas.
This is my favorite time of year. Hey, did you hear that? Let's check it out. Legendary Pools and Spas.
Today I'm here to talk to you guys about water chemistry, the do's, the don'ts, the hows, the whys, and hopefully make it easier for everyone to understand the importance of maintaining proper water balance, sanitizer levels, breaking down the yuck that accumulates in the pool water. And we're going to do these things in a simple format, and I hope that everyone gets something out of this. Now, during this presentation, you're also going to be able to text me questions to 616-889-6695, and at the end of this presentation, we're going to go through and take some of those questions and hopefully answer them for you. So I guess without further ado, let's get started. When we talk about water balance, we're actually talking about some specific factors that we look for to make sure that the water stays healthy. Those factors are pH, water temperature, calcium hardness, total alkalinity, and something called total dissolved solids. Now, total dissolved solids doesn't get talked about too much in the world of water balance, but I want to make sure that we touch on this and you understand it. We'll get to that later, but understand that it's an important factor that often gets overlooked. But what's the most out front factor that everybody sees and everybody wants to talk about? pH, right? The potential of hydrogen, right? So people ask me all the time, say, John, what's pH? And I said, well, simply put, it's the negative logarithm of the total hydrogen ion content. And then they stare at me with a blank stare. Here's what I want you to remember. pH, number one, is a math problem, but who cares? It is measuring the quality of your swimming pool water. And this is important. I'm going to say this a lot. It measures the quality of your swimming pool water. pH is nothing more than a simple scale. This scale goes from 0 to 14. It doesn't go to negative numbers and it doesn't go to 15. Okay? This is it. It's set. And on this scale, 0 we consider acidic, corrosive, dissolving. At 14, we consider that basic or caustic or scale forming. And number 7 is the Switzerland of pH. It's neutral. It's neither scale forming nor corrosive or acidic. Now here's what's important to remember. Remember I said this thing is logarithmic, right? So a pH of 6 is not one less than 7. It's 10 times more corrosive than a pH of 7. A pH of 5 is not 2. It's not even 20. It's 10 times 10. So a pH of 5 is 100 times more acidic than a pH of 7. Now, if you had a cut on your hand and stuck it into a bucket of water with a pH of 5, you're probably going to know you have a cut on your hand. It's going to feel a little tingly. It might burn a little bit. Now, on the other side of the scale, say a pH of 9 or 10, right? Well, it's not acidic, it's not corrosive, but what happens is now the water can't hold all that stuff in solution, so it wants to let it go. The water starts to cloud. You'll see some white chalkiness start to form on surfaces and handrails and things like that. And so it's important that we keep the quality of our water in a specific range. The correct pH for a swimming pool is 7.4 to 7.6. And why is this? Well, not only do we want the pool to be, our pool's water quality to be balanced, but we also need it to be comfortable for the swimmer. And so the tears of our eyes are somewhere around 7.5. Again, 7.4 to 7.6 makes it comfortable on the swimmer as well. So remember, pH is merely the measurement of your pool water's quality. Now, how do we maintain the correct water quality? Well, we use a buffering system in our swimming pool called total alkalinity. And total alkalinity is actually physical, hold in your hand stuff that we're measuring in the water. So if pH is this mythical scale that we can't see, touch, smell, or taste, total alkalinity is physical, hold in your hand stuff that drives that water quality. A lot of people refer to it as a shock absorber for your pH, right? It keeps things in line. We use this stuff to make sure that our pH stays at a balanced level. Another slide just to give you an idea of what that means. This slide's, honestly, it's kind of old as I am, so I just like using it. But it shows you that ring of protection, right? It just keeps that pH where it should be. What do we want for total alkalinity? 80 to 120. Now, I'm going to tell you something that's probably shouldn't tell everyone, but in the olden days, back when I started, there actually used to be two sets of numbers for total alkalinity. One for vinyl liners, another for gunite or concrete pools. And the reason I mention that is because later on we're going to talk about something called the LSI. And I'm going to show you how you can manipulate these numbers to make sure that your water quality stays within range. And those ideal numbers that we're looking at for total alkalinity, we're going to look at some other ones, might fall out of that ideal range, but I can still keep the water in balance. So just important to understand that. So total alkalinity is the stuff that drives the pH, water quality. Now, that said, I'm going to introduce you to another buffering mechanism for your pH that really makes life a lot easier on everybody. So, our current buffering system, this total alkalinity, is comprised of carbonates, bicarbonates, and hydroxides in the water. Okay, that's great. The problem with that buffering system is that it is very easily reacted to by acid in the water. Now, acid in the water reacting with carbonates can cause CO2, and when that CO2 leaves the water, the pH rebounds, comes back up. Let me get into it a little deeper for you. I know it's weird. So, when our pH or total alkalinity is high, right, we use acid to bring it down, right? It's scale forming. We want to bring it more towards the acidic side. We add acid. That acid actually forms carbonic acid in the water, and the pH decreases. Great. That's what our objective is. True. But a portion of that is actually shifted to aqueous CO2. Now, CO2 leaves and re-enters the water through the atmosphere all on its own, okay? The problem with that is, as that CO2 leaves, the pH comes back up. Here's a little factoid for you. So, in the world of commercial pools, right? What do we use to drop pH? CO2. Why? Really cheap. We can install these big tanks, pump it into these Olympic-sized pools, drop the pH. Perfect. You ever hear of anybody aerating the water, right? They point the jets up at the surface to aerate the water. Well, what they're doing is driving CO2 off. They're raising the pH. And so these little tricks that people may not realize is actually what we're doing behind the scenes. So this is one of the faults with solely relying on carbonate value to be our buffering mechanism for our pH. 5 seconds of wisdom. The oldest known pool was built in Pakistan in the 3rd millennium BC. So, how can we improve our buffering system for our pH? Well, there's something called borate. And this stuff is probably the least used chemical that we have in the swimming pool industry. This stuff is mined. They dig it up out of the ground. It's a white powdery substance, right? But the beauty of borates is it's not affected by that acid like the carbonates are. So what does that mean to you? It means a very stable pH and without having to worry about those swings. So we can maintain a much better water balance or water quality by the addition of one product, borate. Now, in addition to that, which there's the nerdy chemistry side of me, right? That's what's important to us as service people and pool retailers and water testing, right? We're maintaining balanced water for homeowners at all costs, right? We add a little borate to the water, it does that. But what it also does, at Haviland, we actually make a product that's EPA registered as an algistat. So borate also keeps algae from reproducing. If anyone has ever used Visine or eye care solutions, right? If you look, the base chemistry is borate, okay? So now I can reduce the red eye, the irritation from swimming. So if Mrs. Jones, she wants to put her kids in a solution of Visine to swim, oh man, doesn't that feel good? We talked about buffering the alkalinity and the pH, but by keeping that algae from reproducing, we also reduce our sanitizer consumption in the water. Now, borate not only helps with stabilizing the pH and maintaining that water balance, but it's got corrosion and scale inhibiting properties to it. You can use it with any form of sanitizer. Doesn't matter what you're using. Salt chlorine generator, chlorine tablets, liquid, even polymeric guanides. And it's not affected by the UV rays of the sun. So you ask yourself, all right, John, what's the trick? This thing can't be the magic bullet. Nah, kinda. It kinda is. It does all those things. It makes pool water better. It just makes things work. The quality of the water. There's just a shine, a sheen, a sparkle that you get to the water when you're using borate that you won't see on a standard chlorinated pool. Hard to describe. Something that really should be put in every body of water. There's no reason for it. So we understand that the stuff, the total alkalinity, right, the carbonates and the borate, helps to balance or maintain the quality of our pool water, the pH. Well, there's some more stuff that we're going to talk about, and that's calcium hardness. And calcium hardness is one of those, again, a little bit neglected as far as testing goes, because this stuff can really protect the surfaces of our swimming pool. I'll tell you this, Mother Nature always wins, okay? And think about this for a minute. We're trying to do something in a swimming pool, in a body of water, that it does not want to do. Because what happens if you dig a hole and fill it with water? Some algae starts to grow, you get a couple plants growing in there, the frogs move in, it becomes an ecosystem. It's going to do what it wants to do. we're trying to make a swimming pool do what we want it to do. And so we need that calcium hardness in the water. If you don't, what happens? Mother Nature's going to try and right itself. It's going to grab that calcium from whatever source it can. A little bit, here's a good story for you. So many years ago, there was a university, and I won't tell you which one, but they had refinished their swimming pool, and all tile, gorgeous, and they were sold some new sanitizing equipment for this pool. It was a copper ionizer, and because this pool is so massive and the size of things, so they were required, because we're using metals to kill bacteria now, okay? So they were required to maintain a pH of no greater than 6, a total alkalinity of somewhere between 250 and 350, I can't remember exactly, and a calcium hardness of 0. And this pool was running, the swim team loved it, great, no problems. Well, you got to remember that swimmers don't like body hair, okay? They shave themselves, right? It's resistance. They need to be clean. They got to go fast, right? But the people that use the pool on the weekends, you know, you could pay a membership and you could come in and swim, that kind of stuff. They offer those services. The university started getting complaints that their hair was falling out. And so at first it was like, yeah, whatever. And then they did some research. And what they found was that since the calcium level didn't exist in the water took it from whatever source it could. The people. Now, the fat hairy guy with the hairy back, man, he was excited because he didn't have to manscape. He didn't have to do nothing. But Mrs. Jones, that was going in for her new permanent once a week, not happy. So the point of my story is that we need these things in the water because we're trying to make water do something different than it wants to do. Mother Nature always wins. Now, this is something interesting for you. So remember I talked about those borates and how cool they were and they do all these different things? Well, what they also do, remember I said it was a scale inhibitor? Well, they bond to calcium. So if your calcium level was real high, it would help to keep that calcium in solution. And if it did fall out and try and scale things up, it would make it much softer and easier to remove. So again, borate makes things better. Calcium hardness, where do we want that in a swimming pool? 200 to 400 parts per million. Again, I will show you a little bit later that these numbers can be manipulated a little bit to make sure that you maintain proper water balance. Again, there used to be 2 sets of numbers. Now there's just 1. TDS, this is that one I was telling you about that gets neglected a lot, okay? Total dissolved solids. We're talking about all the stuff that you've thrown in that water that's just floating around in there. You can't see it with your eyes, but it's there in the water. And the water can only hold so much of this stuff. And what I try and relate it to me as a kid making Kool-Aid, right? So when I would make some Kool-Aid, my mom would say, just use 2 scoops. Okay. So I'd put in 4 and I'd mix it up. Nah, not sweet enough yet. Put in another 4 more. Mix it up. Yeah, not bad. Could use a couple more. So I put in a couple more. The problem is now it's not getting any sweeter, but I got 2 inches of sugar at the bottom of that jar, right? Same thing with TDS. right? The water can only hold so much. It's not, nothing else is going to work properly if that number's too high. Now, in a perfect world, we'd keep that TDS number less than 1,500 parts per million. But as we all know, the world is not perfect. And for years, we always said, okay, once you get to 1,500, I want you to drain some water. Well, then they bumped it. Once you get to 2,000 or 2,500, we want you to drain some water. And then they said, oh, well, maybe 3,000. Well, salt came into play. And salt blew this whole thing out of the water, right? Because you're starting at 32, 34, 3,600 parts per million. And so what we're saying now is that wherever your TDS started at, let's say you started at 800 parts per million. When it increases 1,500 parts per million, then we want you to drain some water, because physical removal is the only way to get rid of this. Unless you live out west and you've got an RO rig where you can pump this thing and just circulate that water and remove everything out of it. But for us here in the Midwest, we don't, water's a little more plentiful. We drain, we refill. So 1,500 beyond where you started, time to drain some water. So again, TDS, important, needs to be tested. You don't need to test it every week, but at least test it maybe once a month. We can track and follow and see how things are working. I can test TDS and tell if people are lying to me about what they're using for chemicals. Give you for instance. So if you are a avid liquid chlorine user, your TDS level is going to jump dramatically in a month's time. Just because there's more unsoluble stuff in that jug. I know it sounds weird. Nobody believes it. But yeah, you add to that level. So, all right, TDS, important. And here's why it's all important, okay? Remember I said this thing called the LSI? Well, there was an old guy back in the olden days, and he had come up with this formula to help out the people that were using boilers, which dominated, back in the 1900s, right? That's how things were heated. That's how trains moved, right? I mean, you used boilers. And what would happen is they would scale up, obviously. And so he came up with this, again, another math problem, to determine if the water was scale forming, corrosive, so we trying to keep it in balance. And again, I always say it, Mother Nature always wins, okay? And it's important to understand, because we're going to use this math problem to make sure that we win the game, not her. And so we take those factors that we talked about earlier, right? The only one I didn't just say was the temperature. You get temperature, calcium hardness, alkalinity, pH, TDS, and you throw it into this simple math problem. Look, it's 3 pluses and a minus. Easy. You plug all this stuff in, and it spits out an answer to you. And we want that answer to fall between negative 0.3 and positive 0.3. If it doesn't, then we need to do something to the water to get it there. I may need to increase my calcium count. I may need to decrease my alkalinity. You need to do something. We need to get it within that range. 5 more seconds of wisdom. According to the Red Cross, 50% of Americans can't swim. It's interesting. All right. Now we're getting into some stuff that is equally important. So we understand that the stuff that we're measuring in the pool water drives the quality, the pH of that water, okay? And that keeps the water in balance so that things are protected. We're not dissolving things. We're not scaling stuff up. But what about the people, right? we need to make sure that the people stay safe and don't get sick without disease or infection or anything like that. And we do that by sanitizing the pool water and oxidizing the waste that accumulates in that water. Okay? It's important for you to understand that we want to separate these two concepts. Sanitize kills the critters that make us sick. Oxidize breaks down all the yuck that we've introduced into that water. Okay? Now, here's how we sanitize. And we're using chlorine for these purposes simply because it dominates the market. You can't do much. My name tag's falling off here. So we're using chlorine for the purposes of this presentation, simply because it dominates the market still. But here's how I want you to understand this. So chlorine, when added to water, becomes this stuff called hypochlorous acid. And that is the stuff that kills that bacteria that makes us sick, okay? And we measure that killing agent as free available chlorine in the water, okay? Free and available, which means it is active and can be used to go after those things, okay? The ideal range is 1 to 3 parts per million. But here's a little note, or a little tidbit I will give you. I prefer to bump you up towards that higher side of ideal. And here's the reason for me saying that, is that at no point do we really know what the demand in that water is, okay? So I say it this way. So you're running at a 1 part per million chlorine count. Everything's fine, hunky-dory, woohoo. We're going good, right? Well, then your scummy neighbor decides that he's coming over and jumping in your pool one night. Well, he just chewed up that 1 part per million. So now when you go to use the pool, there's nothing. Now you have no protection against the things that can make you sick. And if that guy's that scummy and nasty, I'm sure he's dropping some stuff into that pool. So it's important to understand that. I want you between 1 and 3. It's acceptable, but take a little advice. Bump it up towards that 3 part per million. Trust me when I tell you that you're not going to notice the difference. It's not going to be horrific on your skin, your eyes, especially if you're using borate. If you're using borate, you really realize a bunch of advantages, especially in that that feel of the water, right? So 1 to 3, that's where we want you. So if we understand that chlorine sanitizing kills the critters, we got to understand the oxidizing portion of this as well. And so we use a term called shocking in our industry that is really one of my pet peeves, because it doesn't tell me what I want to do. And so I say it this way. What's my objective? When I'm talking about shocking a swimming pool, what's my objective? Do I need to break down a bunch of waste in the water? Do I need to break down something called chloramines? We'll get to that in a second. Do I need to kill algae? Do I just need to increase my chlorine level? Well, it all falls under this umbrella of shocking. And I never forget that the first time I was in the pool and just floating around having the Pabst Blue Ribbon, and I told my wife, I said, hey, we need to shock the pool. And she ran out with a toaster and threw it in. Come on, you can laugh. Sometimes they're not as funny as other ones. So anyways, we want to shock the pool water. But what's our objective? Well, there's 3 types of things that we do when we, quote, shock the pool, right? We can use a non-chlorinated product. We can use a chlorinated product to do one of 2 things. Either to break up some chlorine byproducts that accumulate, break down some organic stuff that falls in there, or kill algae. So here's how we're going to do that. My personal favorite weekly maintenance product is a non-chlorinated oxidizer. Okay, this non-chlorinated oxidizer, okay, we call it Oxone in the swimming pool world, is a outstanding product to use to break down all the yuck that we introduce into the water, okay? It also helps to break apart things that, so when as chlorine's working, some of that chlorine gets tied up with other stuff in the water, okay? We call those things chloramines. We'll get to that in a second. Non-chlorinated shock, best product to use to break that stuff up. Now, even though you can resume activity in the pool after 15 minutes, I always tell people, you know what? Let the product do its job. Because if you jump back in 15 minutes, what good's that doing? You just added more junk to the water, then I got to reoxidize it again. So let it work. Now, remember I told you about that chlorine that gets tied up with stuff? Well, we call those chloramines, okay? And if I were to ask you how to find the hotel pool, what are you going to do? You just follow your nose and it takes you right there, right? That ammonia-y kind of smell, right? That real chlorine-y stuff that you're smelling. Well, that means that there's not enough free and available chlorine in the water. That means a lot of that chlorine is tied up with other things. And we need to break that apart, okay? And how do we do that? The best way to do it, non-chlorinated shock. So these chloramines in the water are nasty, right? It's not allowing our chlorine to be active at killing the critters again that make us sick. Let's say you didn't have any non-chlorinated shock to use. Well, we can use it. We can do it a different way. We can use chlorinated shock to do this as well. To do that, we use this 10 times rule, okay? And I won't get into the math for you, but we basically say this. Our free available chlorine is at 1 part per million. Our total chlorine, which means the stuff that's in the water but just tied up, is at 4 parts per million. The difference is 3, right? We multiply that by 10, figure out what type of chlorine we are going to use. Then we go to this chart and we do this math, and boom, it comes out with this answer. Mrs. Jones, you need 20 pounds of calcium hypochlorite to break up these combined chlorines in your swimming pool. And I get the look of, no, I'm not. Yeah, that's what we need to break this up. Here is the problem with this method, okay, is that we know how much stuff is tied up in the water, but we don't know how much other stuff is in the water. Let me say it this way. I don't know what the demand is, okay? I know I have this much chlorine tied up, but there could be a whole bunch of other stuff floating around over here. So when I add that 20 pounds of chlorine, what happens? Well, it attaches it to this stuff over here. So now instead of 4 parts per million of total, I've got 10 parts per million. I just made the problem worse. And so the use of non-chlorinated shock doesn't do that, okay? I might not go from 4 to 1. I might only go from 4 to 2 or 4 to 3, but I didn't make it worse. I didn't make the problem worse. So if you have a combined chlorine issue, always default to non-chlorinated shock. If you do, remember, we want to make sure that we're oxidizing stuff as a program, right? I want to do this all the time. I need to be able to maintain or stay up with or not fall behind, because as things accumulate, right? If I don't oxidize frequently, stuff gets, the snowball rolling down the hill is getting bigger, right? And so now it's going to take more stuff to do the same thing I could have accomplished with a few ounces. So again, put yourself on a program. Do this weekly, or maybe more than a week. If your pool's getting tons of use, you might be oxidizing that thing 2-3 times a week. Remember that. Spas, hot tubs, you could be oxidizing those things after every use if you got 3-4 people in there. So remember, proactive, not reactive. And finally, we talk about algae. We need a chlorinated shock. The non-chlorine stuff won't do anything. I can't use oxone for this method. But remember, I also want to make sure, depending on the severity of the algae, that I get to 15, 20, 30 parts per million of chlorine to make sure I kill all that algae. People try and underdo things a lot, right? And so if you put in 1 bag of chlorinated shock per whatever, follow the label directions, okay? And it actually requires you to use 3 or 4 bags. Well, that 1 bag didn't count. So now you got to do it again. So trust in your pool professionals and make sure that we do the right things. But important to understand here, for killing, again, we need chlorine. 5 more seconds of wisdom. The very first music CD pressed was Born in the USA by Bruce Springsteen. We understand that the stuff, total alkalinity, borate, calcium hardness, keeps the quality of our pool water, the pH, in balance, and that our sanitizers, chlorine, kill bacteria, and we oxidize the non-chlorine shock, the yuck in the water. Well, what happens if we're doing all that stuff and then somebody wants to play a joke on us, right? There's some stuff called phosphates, and they're floating around in the world, and they're all over the place, and you can't get rid of them. It's in your laundry detergent. When you want your green grass, you're putting phosphates into the lawn. The problem is that they're not real compatible with pool water. They do some bad stuff to it, okay? And what happens is these things get into the water and they actually reduce the effectiveness of your chlorine. They can combine with calcium if you have a salt chlorine generator on the pool to create calcium phosphonate, which is nasty, nasty stuff, which causes all kinds of issues. You can't produce chlorine through your generator. You get scale formation on stuff. So it's something that we need to make sure that we either reduce the amount or eliminate it. It's tough to eliminate it completely because it's always coming back. But again, if it's not there, algae doesn't have that real nice nutrient for it to reproduce. So what do? We add a phosphate remover to the water, okay? Important to understand, and I will emphasize this, and we'll get to it in a little bit, that chemically we can do all kinds of cool stuff, right? But physical removal of particulate is done by your filter, okay? I'm going to say that again. Physical removal of particulate is done by your filter. It's the filter's job to take stuff out of solution. We can do all kinds of different stuff chemically. I can bind stuff together, make it bigger. I can knock stuff to the floor. I can increase pH levels, decrease these. I can't remove it. It's the filter's job. And so how these phosphate removers work is you pour this stuff in and it bumps into a phosphate, okay? And now your filter pulls it out. Some of them will actually knock things to the floor, but the physical removal is already done by the filter. I'll tell you what, we got a really cool product too, because ours will pull out 5,000 parts per billion. So really good stuff. Anyways, that's phosphates. The bathtub ring, the yucky stuff in the water. We're going to talk a lot about yuck, right? But there's something to say about washing or bathing before you use a swimming pool, right? Well, nobody does that, okay? And what they do the actual opposite of that, right? What happens? Mama says, come here, little Johnny. What? I'm going to put 6 gallons of SPF 2000 on you, and then you jump in the pool. Where you think all that stuff goes? In the pool. You think Mrs. Jones just, with all her hair product and her lotions and the thing, all that stuff goes into the water, okay? And so what happens is it rises to the top, right? Sticks along that water line and gives you that brown, sticky, gross yuck line in the pool. And so what we can do is use something called enzymes. And enzymes actually can break down that yuck, okay, to allow our oxidizer to work much more efficiently, okay? These enzymes are just chains of amino acids, and they're just looking for this specific shape, and they lock on the shape, and then they chomp on it for a little bit, and then they spit it back out. It's important to understand that they don't consume it and then just float around as a big blob of something in the water, right? They break it down, spit it out so that our oxidizer can use it, can be used more efficiently. This gives you a little idea of how an enzyme works. Now, here's what's important to understand about enzymes. Enzymes are very specific, okay? I'll give you an idea. You couldn't take your liver enzymes and stuff them in your kidney. Not compatible, and you would probably take a dirt nap, okay? So, enzymes are specific. So one of the keys is to have a product that encapsulates as many different lock and key configurations as you can possibly have. And one of the things that we're pretty proud of is developing a formula that's actually used outside of our industry in other applications. So we do more than just oils and lotions and things like that. And that's where enzymes are your friend. Now, what if you have phosphates and yuck in the water? We got a product that does both. This is actually a great maintenance weekly product. You just add in a few ounces every week, and what are you doing? You're keeping the phosphates out. You're keeping the yuck at bay. Awesome maintenance product. Again, how do we use it? Well, you shake it up, you pour in a few ounces, and let it work. Oh, 5 more seconds of wisdom. The first swimming goggles were made from tortoise shells in the 14th century Persia. Rubber goggles were not invented until the 1930s. I don't know how you swim with tortoise shell goggles, but all right, we're getting to the end here, folks. So we talked about the stuff that drives the quality of the water. We've talked about sanitizing, killing the critters, oxidizing the waste, getting rid of the phosphates and the yuck that make our life more difficult. And we can't do any of that stuff unless we have proper circulation, filtration, and a word that I made up, cleanation. So again, we're talking about doing something to a body of water that Mother Nature does not want it to do, okay? And to do that, we need to put some stuff on here: pumps, filters, skimmers, chlorinators, heaters. We got to add stuff to this body of water to make sure it does what we want it to do. And it all starts with circulation. And when I say circulation, I mean I got to make sure that the water is moving properly, okay? Here's the biggest thing that goes on with a swimming pool. So we size these plumbing lines and get this pump and this filter to maintain the gallons per minute and all these different things. And then we put in the wrong return jet eyeballs into the pool. Or we shoot them the wrong direction. So it's important. You need to make sure that you properly size the eyeball. You also need to make sure that it's pointing in the right direction. I want things to move so that they can get sucked back down through the skimmer. If I got all the jets just pointing willy-nilly through the water, I'm not circulating anything. Now I got bad dead spots and things grow and I got problems. So circulation, important. That's where it starts. And the biggest favor you could do yourself is buy a good filter. Filtration is the key to everything. Again, physical removal of particulate. I'm not going to tell you what style of filter to buy. There's cartridge, there's DE, there's sand. They're introducing some new media for sand tanks now, like glass. If you have still sand in your tank, you may need a little help. They make additives to help tighten up those sand beds so that you can pull out finer particulate. And let the thing run. Let it run. With the technology that we have today, with variable speed pumps, there's no reason that filters should be, honestly, because I grew up with guys that made us run them from the beginning to the end of the year. That was it. The thing never shut off. I don't pay your electric bill, but what I can tell you is the pool can only be as clean as the pump and filter allow it to be. So I can do stuff with chemicals, but I can't take anything out of the water. So remember that. Filter, filter, filter. And lastly, I talk about cleanation. This is one of the things, and I really think that it gets neglected in the world of swimming pools. Brushing the walls, brushing the surface of the pool. There's some stuff that, and over the years, you'll find that different algae and bacteria and growths come into play that build up immunities to what we're trying to do. And by brushing the biofilm, the things that can cause that stuff that makes us sick in the water, by brushing those walls, you eliminate those things. And there's always going to be some dead spots with your circulation. But if you can circulate the water through those corners and things that your robots and vacuums can't get into. Brush the swim. So here's how I do it. On Saturday morning, I wake up, I grab my beer helmet and load it with 2 Pabst Blue Ribbons, go out to the pool and start brushing. When it's time to reload, I'm done. Now I can start my day of just lounging by the pool and drinking. So, but remember, brushing is hugely important to healthy swimming pools. And don't forget to do it. It needs to be done. So finally, I'll leave you with this. What do we want to remember? We need to balance the water. Borates make balancing way easier, right? We need to sanitize, right? We need to kill the critters. We need to oxidize. We need to break down stuff in the water. We need to physically remove the phosphates. Chemically, we can add some stuff to make them bigger so that the filter can pull them out. We need to break down all those body oils and lotions and the rest of that yuck so that our oxidizer can complete the process much easier. And finally, we need to circulate, filtrate, and cleanate that pool. And I think that if you follow those simple steps and understand that we want to maintain proper water balance so that the quality of our pool water maintains where we want it to be, I think we'll be good. I think we'll have a really good summer. I'm excited about what's about to happen. This kind of stuff is a little weird for me because I've never done it before. I'm used to having some crowd participation. Well, and I'll show you what my little makeshift studio here, so everybody can kind of understand what's happening here with my little makeshift stuff. So hopefully we'll get back to normal here in the world real soon, and we're gonna have a really good summer. I'm really excited about it. So until then, we'll see you next time.